Okay, so the last video was about 30 minutes long. If we hold to that for each one of these next two, it would be about an hour and a half, which is good because it's about the length of a normal class. A little bit shorter, actually. So let's go ahead and get started. 12.6. What's going on? What is going on? There we go. 12.6. This time we're actually going to go further into properties of logs. So some of the stuff that we can do with logs, which is going to make it easier to be able to solve problems, which ironically we won't get really heavily into in this semester. But again, if you go on to a college algebra class, you will have to be able to solve logarithmic functions. So you're going to need to know these properties. Okay, again, let's go back. A log is an exponent. So if you think about some of the properties that we've talked about algebraically in the past, they still hold true. If you were to take something like x squared and multiply it by x to the third power, so that should be a 2. X squared times x to the third. These two things have common bases. When you multiply common bases, we should add the exponents. That would be x to the 2 plus 3, which is the same as x to the fifth. Logs hold the same properties. There is the product property of logs, which says that if I have a log base b of xy, well, remember, again, logs are exponents. These hold the same properties as exponents. These have the same base. The base is b. So what I can do is I can write these as the log base b of x. And what did we say we do with our exponents? Because this is one exponent. The log base b of y is another exponent. Since these two things are being multiplied together, we will add the exponents. So plus log base b of y. Okay, this is the product property of logs. Product property. There we go. So basically the idea is if you have two things in the argument being multiplied together, you can split them into separate logs through addition. And that's what's called the product property. And we're also going to have to know how to go backwards so that if you have two things that are written like this with the same base and you're adding them, you can condense them into one log. And we'll go through some problems where we have to do both of those two things. All right, so let's see if we can do a couple of examples here of this. All right, first example. If we have the log of 10 with a base of 11, and we are adding it to the log of 3 with a base of 11, and I want to write this as a single log. I'm going to take this property and go backwards. The bases are the same. I am adding the logs together, so if I'm going to do that, I'm going to take this x and this y, the two arguments, and multiply them together in one log with the same base. So this becomes the log base 11 of 10 times 3. But of course that can simplify, so this is the log of 30 base 11. Okay, so I took these two logs and put them into one log. It's called condensing logs. I put it into one log, and the only reason we can do that is because the bases are the same, so we're using the product property to put it into one log base 11. And you multiply the arguments together, because multiplying the arguments, multiplying things with common bases, you add the exponents, which is what these are. All right, let's do another one where we have to condense. The log of 1/2 base 3 plus the log of 12 base 3. Okay, check that the bases are the same. They are. This is being added, so I can condense into one log base 3 by multiplying the arguments together. 1/2 times 12. Half of 12 is 6. Okay, one more example. And this is where it actually becomes more important, is when we start dealing with variables. So we'll have the log of x plus 2 base 2 plus the log of x base 2. If I were actually going to try and solve something where I had an equal sign, it's equal some value or something out here, what I would have to do is I would have to condense these logs, and this is the purpose of doing this. They have the same base. I can write them all as one log with a base of 2, and then I will multiply these two things together. So this is going to be x times x plus 2. And certainly that can be, should probably put that in a bracket, that can be distributed to be the log of x squared plus 2x base 2. And now I've condensed that log. All right, the second of our properties is the quotient property. So once again, if we kind of go back to the idea, let me use a different color, let's go green. If we kind of go back to the idea, let's extend this page a little bit. Let's say we had x to the 5th divided by x squared. Remember that the idea was now we have common bases which we are dividing. You subtract the exponents. Okay, and this is from previous stuff, so this should all be review. So that'd be x to the 5 minus 2, or x cubed. Same general concept for logs. If we have the log of x over y, now we're dividing two things with the same base of b, so it's a common base. Log of x over y with a common base, we're going to subtract the exponents. And remember, logs are exponents. So that would be the log of x base b minus the log of y base b. So anytime we have a division in here for the argument with the same base, we can separate these two things through subtraction. Or if you see subtraction, we can condense them into a division problem. Order here makes a difference. Okay, whatever's being subtracted always goes on the bottom. If it's being subtracted, it will go on the bottom. Even if there's just a negative out in front of here, that goes to the bottom. So if it's a minus sign out in front of the log, it will go to the bottom. So let's see if we can do a few examples of this. Let's condense, or write as a single log, log 27 base 10 minus log 3 base 10. Okay, we want to write that as one single log. They are being subtracted, so we'll make it a division. This one is the one that's being subtracted, so it will go to the bottom. The bases are the same. We'll have a log base 10 of 27 divided by 3. And in this case, we can actually do 27 divided by 3, so we'll simplify that to the log of 9 with a base of 10. Okay, moving along. Log of 8 base 5 minus log of x base 5. Bases are the same. We have subtraction, so this will become a division. When I condense this, it will be the log base 5. This one has to be on top because it's a positive out in front of here. This one's getting subtracted. It goes to the bottom. So that will be 8 over x. Log of 8 over x base 5. Nothing to simplify there because we don't know the value of x. X here obviously cannot be 0 because that would give us an issue. Okay, extend the page a little bit more. Third example. Log of x squared plus 5 base 3 minus log of x squared plus 1 base 3. Bases are the same. We have a subtraction. This one divided by this one into 1 log. 1 log base 3 of x squared plus 5 over x squared plus 1. We have condensed using the quotient property these two logs into 1. Let's go back up here real quick and just write up here that this was a quotient property. All right. There is one more property that we're going to talk about. Let's go with blue. So, again, we'll go back to our basic example here, that if we have x squared now raised to the third power, not to be confused with x squared times x cubed, that was x to the fifth. We added those exponents. In this case, we have x squared to the third, which means x squared times x squared times x squared. So if I were to write all those out, I would have a total of 6 x's, which is why when we have a power raised to a power, we multiply the powers. So that would be x to the 2 times 3, which is x to the 6th. Okay, same general idea with logs. Again, because logs are exponents, they really do follow the same patterns. Whoops, too far. So if I were to take the log of x to the r power, is what I think is what your book uses, base b. Remember that ignoring the r, if you just kind of cover up the r, we've got the log of x base b. That's an exponent. But this exponent is being raised to another exponent. If that's the case, we can literally multiply the exponents together. So to write this, I can bring that r out to the front, and it is now being multiplied by my exponent, r log x base b. This exponent is being multiplied by this exponent. So the properties still hold true. And this is called the power property. Okay, most people just think of this as, if I have an exponent on my argument, I can just bring it out to the front and multiply it. And that's really what you're ultimately probably going to think of when you're doing these and rewriting them. So let's use the power property to do the log of x cubed base 5. And we simply want to rewrite that using the power property. Well, I have an exponent here, which is on my argument, x. That exponent can come out to the front and get multiplied by the entire log. So I can bring the 3 to the front and make it 3 log of x base 5. All right, let's do one more of those because I want to show you guys something that might not be as obvious. Let's do the log of the square root of 2 base 4. We want to rewrite this using the power property, but you might think to yourself, well, wait a minute, there's no power on 2, but there is. Remember that a square root is the same thing as a 1/2 power. So this is the same as the log base 4 of 2 to the 1/2 power. Now you can clearly see the exponent here. That exponent can be brought to the front of the log. So this is the same as 1/2 log of 2 base 4. Okay, these are the same thing. And then if you had to go backwards, you could take the 1/2 power, put it up here as an exponent. You could take the 3, put it up here as an exponent, and then you'll be back to this. And that'll go to the condensing part of it, which we'll practice here in just a second. So what we're going to do is we're going to try and put all these properties together to either expand or condense logs. And that's going to take us through the bulk of the rest of this section. All right, so let's create a new page. Feel free to do so as you would like. I'm going to extend this just a little bit so I already have the extension. All right, we're going to put all these properties of logs together now. All right, so let's condense or write as a single log the following problems. 2 log of 3 base 5 plus 3 log of 2 base 5. All right, so we want to put all this together into one log. So here's the idea. In order to put it all together in one log, we kind of have to follow the properties that I just told you backwards. The first thing you have to do is you got to get rid of any coefficients out in front of the logs. So what we can do with these is we can bring these up to be exponents on each one of the arguments. Right, so that's the first thing we're going to do. So this will become the log base 5 of 3 squared plus the log base 5 of 2 cubed. Now in this case we can actually do 3 squared and 2 cubed. That's something we can do. If there's variables there, sometimes you won't be able to do anything with it. So let's go ahead and simplify that. That'll be the log of 9 base 5 plus the log of 8 base 5. Now what you should notice is that these two bases are the same. I have an addition. Okay, if you remember what we just talked about, if we have an addition, the two bases are the same. To condense this into one log, we'll multiply the arguments together. So 9 times 8 is 72 base 5. I have condensed this into one log, base 5. All right, let's see another one. Let's do 3 log of x base 9 minus log of x plus 1 base 9. So the first thing you look for is you look for any coefficients, because we have to make those exponents. I've got a 3 out in front of this one. It has to come up here as the exponent. So we're going to have the log of x cubed base 9. This one doesn't have any coefficients, so we're just going to write minus log x plus 1 base 9. But what I now see is a subtraction. Remember, the thing which is subtracted goes on the bottom. We can condense these two because they have the same base. So this will become the log base 9 of x cubed over x plus 1. And I have taken these two logs and condensed them into one. All right, let's try one more, and this is going to have multiple pieces to it. So we have the log of 25 base 4 plus the log of 3 base 4 minus the log of 5 base 4. Okay, the first thing I'm going to notice here is that I don't have any coefficients. There's nothing out in front of any of my logs other than pluses and minuses. So I don't have to worry about bringing any powers up. I also have the same base. The first two are being added together, so those two are going to get multiplied. This one is being subtracted. It's going to get put to the bottom. So when I condense this into one log, base 4, it should be 25 times 3 on the top and then over 5 on the bottom. And this is going to simplify. Okay, two different ways you can do it. You can simplify it now, or you can multiply it out and then simplify it. If I multiply 25 times 3, we get 75 over 5. 75 divided by 5 is going to be 15, so that's going to be log base 4 of 15. And I have condensed these three logs, using log properties, into one single log. All right, now that we know how to condense, let's go ahead and figure out how to expand. Okay, expansion is actually, I think, is personally easier to do. But that's my personal opinion. So we're going to expand the following logs. First one, log base 3 of 5 times 7 over 4. All right, so the first thing you should see is okay, I have a certain number of pieces of things which are either being multiplied or divided. I have two things being multiplied on top, one which is being divided on the bottom. So when I expand this, I should have three separate logs. 1, 2, 3 pieces. So the first thing I'm going to do is everything on top, which is the log of 5 base 3. And remember, if they're being multiplied, we're going to separate them through addition. Plus the log of 7 base 3, and then the thing which is on the bottom gets subtracted, which is minus the log of 4 base 3, and that's expanded. Nothing else really we can do with that. The only other thing is when you expand these things, if something here simplifies, like you have a log which is easy to simplify, and we'll see probably an example of that at some point, then simplify it. Like if this were a 2, 2 to some power would have to give you 4, 2 squared would give you 4, so you could actually simplify that entire log just to be 2. But that's not what happens here, so let's not worry about it for that example. Again, we're going to expand this log, so it's the log of x to the 5th over y squared with a base of 2. So again, what I see is I see something on top, something on the bottom. Here I only have two things, so I should only have two separate logs. The one which is on top comes first. Since this is in the denominator, it gets subtracted. Oops, forgot my base of 2. They must have the same base. And now the only other thing that you should see here is I have exponents. To fully expand these, I've got to bring these exponents of my arguments out to the front. So I can bring the 5 out to the front of this log. So that becomes 5 log x base 2. And this one becomes minus 2 log, log of y base 2. Simply bringing the exponents to the front. That one is fully expanded. Okay, what if we were actually given some values of these things? So let's say that we're given the log of 2 with a base of b, so we don't really know what the base is 0.43. And we're also told that the log of 3 with the same base is a value 0.68. Let's say we wanted to find out what the log of 6 base b equals. Well, if you use the properties of logs, what we can do is we can add these two logs together, because if we add these two logs together, don't we condense that to the log base b? Multiplying these two things together would give you 6. Well, that's what we're looking for. We're looking for the log of 6 base b. So what that says is the log of 6 base b is taking these two in particular logs and adding them together. Well, I know what these logs are. It's 0.43 and 0.68. 0.43 plus 0.68. Adding those two things together, you get 1.01. So the log of 6 base b is 1.01. Okay, and depending on what values you're given here and what they give you here, you might have to do a little bit of thinking as to how do I get to that value? What would I have to do? All right, so we're really not going to do, well, let's do one more. We'll do one more example. So if I have the log of the square root of 2 base b, and I want to find that value, what you need to think is, okay, this is the same as log base b of 2 to the 1/2, but I can bring the 1/2 out to the front using properties of logs. So this log of 2 base b, I know that's 0.43. So really, this is 1/2 of 0.43. And then if you weren't sure exactly what that was, again, you guys will have the aid of a calculator to be able to figure this out. Excuse me. Yeah, but you guys will have the, excuse me. There, that's better. You guys will have the aid of a calculator to be able to figure this out. Sorry, I know you guys couldn't really tell, but I had to pause this thing for a second. I was having a coughing fit there. 1/2 of 0.43 is there we go, 0.215. There we go. So again, you just have to kind of use some of the properties to figure out what you have given these values up here, and it could give you other things that you might have to figure out as well. All right, that is section 12.6. A little bit shorter than the last one, but not by much. We're doing good. We're right about pace. So we'll come back with 12.7, and that will be the end of the new material for the semester.